Okay guys, exercise 14D, question 9 is what we're currently doing. A uniform disc has mass m and radius r. Is free to rotate about a horizontal axis through a point M on its rim, point P on its rim, perpendicular to the plane of the disc. The particle of mass 2m is attached to the disc at Q on its rim diametrically opposite P. Diametrically opposite basically means it's the other side of the hoop, okay? So, basically going to do is what we usually do, okay? We're going to go in looking at the disc starting off. Everything to do with the disc is going to be in blue. So the disc, its moment of inertia about P is equal to its moment of inertia about its own centre plus its mass times its distance squared away from P. Okay, so we're going to call this as big R, big R. So IP, we look up the moment of inertia of a disc around its own axis, which is a half mr squared. Now remember, this formula is for mass m, which it says it is. Where's mass m? Mass m, radius r. Okay, I'm using capital R for small r at the moment. And then m times, so it's going to be it's going to be m times d squared, which is going to be mr squared. Add it together, we get 3/2 mr squared. Okay, the next one is the point mass.
Why do you use parallel axis here and there rather than...
I haven't used it yet. So now we're going to the point mass, okay? Now the point mass is always the same formula, okay? For the point mass, its moment of inertia around P is always mass times distance squared. Its mass in this case is 2m and its distance squared is 2r to be squared. Put all that in and you're talking about 8mr squared. Okay? Now once you got all that together, what we're going to do is we can reduce this down here. For anybody taking it down. Is that still big enough, is it? Right. Now that's done, okay. We're going on to the system, the mass of the system, okay, which we'll do in purple here. So system is going to be the two of them added together. So it's going to be 3/2. The mass of the system around P is going to be 3/2 mr squared plus 8mr squared. And what we should get there is 19/2 mr squared. Okay, so that's the first part there. Next part is find the disc held for Q. Find in terms of find the angular velocity. We're looking for angular velocity still, okay? Now we're rereading back to the question and we're going to find out what the story is with the angular velocity, okay? So to do this, what we're going to do next is we're going to do the conservation of energy, okay? Now it's very important that we decide where the disc has to have no potential energy at a point. So what we're going to do is we're going to put no potential energy at this point here, because that means that when the point mass reaches the bottom, it has no potential energy. So the system is mgh of the disc plus mgh of the mass, that's potential energy of the disc and the mass, plus the rotational energy, a half I omega squared, equals the new mgh of the disc, the new mgh of the mass, and the new rotational energy of the system. Okay, so remember that's the system, and that's the system there. Okay, now let's begin. At the start, the disc, okay. So guys, disc is 2r above the ground, okay, and its mass is m, so it's going to be mg2r. The next one's the mass, which is 2m, and then g and then it's also 2r above the ground. Half I w squared, we know it's not spinning, is it? Is it spinning at the start? No. It says in the question it's not spinning at the start, so its rotational energy at the start is going to be 0. Equals mgh of the disk. Now, where is the disk centre of gravity at this point in time? It's located distance r above the ground, so it's mgr. The mass has no potential energy because it is lying on the line that it's lying on the reference line, which is the point that has no potential energy. So it's plus 0, and then the next part is going to be a half I. Now what's I? I is, we got I to be, what's a 19 over 2? A half 19 over 2 mr squared. Now what about the rotational energy or the angular speed? Omega equals v over r, omega squared, therefore. Actually guys, we're not changing it this time. Why are we not changing it this time? Because we actually want to find out what omega squared is, because that's part of the question, angular velocity, so I actually have to keep it in. Okay? So that's it all there. First step, I can cancel all the m's off both sides. Then I'm going to have 2gr plus 4gr. I'm going to bring that over the other side. Minus gr equals 19 over 4 w squared r squared. I think that's what it is anyway, w squared r squared. Yeah. Please bear in mind that r is big R, right? I'll just change back to small r for no reason. 5gr ends up to be 19 over 4 w squared r squared. Cancel off r, this one here. Now multiply by 4, multiply by 4, divide by 19, it's going to be 20 over 19. 20 over 19g, and bring down the other r, g over r equals w squared, and w or omega therefore equals square root of 20g over 19r. Okay? Next thing, if the system were to oscillate as a compound pendulum, prove that it would have a periodic time equal to that of a simple pendulum of length 19 over 10r. Okay, so what you need to have of is, for a compound pendulum, t equals 2 pi divided by the length of the pendulum, or sorry, the inertia of the pendulum, over mgh. Okay, once that happens, okay, what we're going to be left with is 2 pi times t. What's the inertia of the system? 19 over 2 mr squared divided by mgh. What's the weight of the full pendulum if we're treating the disc and the point mass together? It's m and 2m, which makes it 3m. G stays the same, and h is the distance away from the line of action. Okay? Now, we have to find out where exactly is the line of action. That's the problem, okay? I don't know what h is, so h is currently stopping me from doing the question. Time to find out what h is, okay? So, what we have here is a disc, like so, and its point mass is at the ends. We also have another disc, or sorry, the same disc, but we're treating as one body. So at the beginning of the question, the mass of the disc, mg, is dead center. The point mass is 2 mg, going directly down. If I treat this all as one system, it's going to be 3 mg going directly down somewhere in between where the two center of gravities used to be of two different objects, okay? So what we do next is we say that this length here is going to be, so we say this length here, we don't know what it is yet, so we're going to call it H, and H is, remember the line of axis, the line of action, guys, is P. That's the axis we're twirling it around, okay? So you have to find the distance, excuse me guys, you have to find the distance from the center of gravity away from the line of action, okay? So here's what we're going to do. Sum of the moments equals moment of the sums, okay? So mg, and remember, from the old axis, it was a distance r away. So it's mg times r plus 2mg times 2r, because this one was 2r away, its line of action. It's now going to be the equivalent of 3mg multiplied by h. And what we get here is 5mgr equals 3mgh. Cancel off the mg's. H equals 5r over 3. So it's going to be 5r over 3. Now all I got to do is go back to the top, replace this with 5r over 3. Cancel off the m, cancel off the r, and let the calculator do the rest of the work, okay? And what we're going to find out is that t equals 2 pi 2 pi the square root of 19r all over 10g. 2 pi times 19r over 10g, okay? Now remember, it was acting like a simple pendulum. This here would be, this here would be a different formula. A simple pendulum's formula is 2 pi root L over G. So what you're doing is you're just going to compare both formulas to each other, and what you can say is, well, look, it's identical if L was 19 r over 10. So that's the length of an equivalent compound pendulum. Okay? Now, a uniform rod AB of length 2p and mass 3m has a mass m attached to a distance y from A. Alright, so basically what it wants from me is a line from A to B. It's of length 2p. Okay, this is point A here, point B here. Now the problem is with this question is the point mass is in the middle somewhere. So mass, the uniform rod of length 2p and mass 3m has a mass m attached to a distance y away. So that's what's going on here is okay. So what's happening here is the mass is a distance y away. The full length of this pendulum is 2p, and that means the center of gravity of this is going to be going through the center at 3mg from distance p from A. Now we're lucky is that the formula is the same as it is for usually the formula for the rod is a length 2l. This converts quite easily to a length 2p, so it's the same thing. So our moment of our inertial moment of inertia around the axis A, because it's going around this direction here. Okay, what it is it's going to be 4 over 3 multiplied by mass multiplied by length squared, or half the length squared. Okay, and that's going to get me 4mp squared. Okay, the point mass. Alright, so look, 4mp squared, yeah. So point mass formula is md squared, inertia around A, and the mass is it's m, but it's y because we don't know its distance away from A in terms of p yet. Okay, so the system therefore is its inertia around A is going to be 4 mp squared plus my squared. Okay, so 4 mp squared plus my squared. Right? Next thing I have to do is I have to go about, if you read the question, okay, it says, prove that the moment of inertia about the system through a small horizontal axis through point A. I did the first part. The system oscillates in a vertical plane about A. Vertical plane about A. Vertical plane. It's different. If the length of the equivalent simple pendulum is 40 divided by 33p, show that y is either 2 over 3p or 6 over 11p. Okay. So what we're going to do first and foremost is we have to treat it like a compound pendulum. Okay? To treat it like a compound pendulum, you're going to have what we had earlier. It's going to be mg down this way, 3mg through the middle. That will turn into the equivalent of 4mg slightly left of centre. Would you agree with that? 4mg just slightly left of centre. Okay? And now that's distance h away from A. And this here being B. Now, sum of the moments equals the moment of the sun. Sum of the moments is 3 mg weight by distance away from axis. Okay? And then the next one is going to be 3 mg times p, because we know the full length is 2p. And this should equal 4 mg times h. Cancel the m's, cancel the g's, and what we'll get is h equals y plus 3p all over 4. Okay? Now, the mass of the system is 4m. Now what's going to happen here is it says, what does it say about the period? Okay, it has the same, what it means by the word equivalent simple pendulum. Does everybody see that? Equivalent simple pendulum. An equivalent simple pendulum must have the same period as it. That's why we're going for the period formula right now. Okay? So T equals 2 pi L over mgh. And what's going to happen here is we're going to get T equals 2 pi multiplied by sorry that's not I, that's inertia. Sorry, that's I, not sorry, it's not L, it's I. Okay? It's the inertia. So we're going to put in the inertia formula as 4mp squared plus my squared. On the bottom we're going to have mass is 4m, g is still g, and h is going to be y plus 3p all over 4. The 4's will cancel. Okay, and then we're going to left with t equals 2 pi square root of, now we can the m's cancel top and bottom, don't they? So we're going to get is 4p squared plus y squared all over y plus 3p. Now there's a g there as well, isn't there? Multiplied by g. Now that we have that done, it has to equal 2 pi square root of L over G. That's the period of a simple pendulum. And the simple pendulum, what did it say the length of the simple pendulum was? Anybody? 40 over 33p. Let's sub that in for L. And what we get is 40 over 33g. Let's isolate the similar parts. Blue here is the same as blue here. So what we can next say is 40p, sorry. what we can next say is 4p squared plus y squared all over y plus 3p ends up to be equal to 40p over 33. Let's cross multiply and see what happens. Okay, so we're going to get 33. Excuse me. What's 4 times 33? 132 p squared plus 33y squared equals 40p. That looks something like a py. Equals 40py plus 120p squared. Now bring it over one side, and what we're going to get is 33y squared minus 40py minus 40py plus what's it, 12p squared? Okay, equals 0. Now, I want you to read, why did I choose y as the variable? That's what you might be asking me. Like it sort of works both ways, so to speak. Show that y is 2 over 3 or 6 over 11. That means y is the variable of the equation. Okay? So that's why I chose it that way. Now, we're going to do, I haven't factorized something like this for you guys in a while, so the way I do it is, I don't do big X because I'd struggle with something this size. I'd go minus b formula to be safe at this one, alright, but what you could do is multiply, what's 33 by 12? Anybody? 33 by 12? 396, okay? Now, start dividing numbers into 396 that you can think of. That would be a really good idea. But let's pretend they're not there, okay? So it does come up with some factors for that, 18 and 22, but the best way to do this is obviously to look up, to see what answer you got for the factors. You can actually work your way back, would be almost an ideal way of doing it as well. So, just looking at this, you do the minus b as well, so I do something like this, 33y squared minus 22y minus 18, oh sorry, that's py in the middle, py plus 12p squared equals 0, then you just take out 11y, and you get 3y minus 2p, and then the other one's going to be minus, what's a 6, is it? Yeah, 6 into 6p into 3y minus 2p equals 0. Then your two parts are going to be this here. Sorry, this is me doing a different method for big X, okay? And then finally your answer will be 11y minus 6p equals 0, y equals 6 over 11p. And then y equals, bring that over to your side, it's going to be 2 over 3p, your two answers. Alternatively, what you could have done was you could have wrote down your answers and worked backwards, so you'd get 11y equals 6p, bring the 6p over to your side, and you get 11y minus 6p in one bracket. And then in the other bracket you could have done cross multiplied 3y equals 2p, and then brought the 2p over and you got 3y minus 2p, and those two brackets fit perfectly into what the equation we just had. So that'd be Carol's way there, would have been the quicker way. Is that the last part of that question? Yeah. Okay, so lads,